All right, hello guys. We are going to go over the chapter, not really a chapter, it's a small unit kind of called climate change. This sometimes is at the end of ecology. I like to put it right after photosynthesis because it talks a lot about how CO2 is taken in by plants and how we as humans, we push out CO2 not only in our bodies, but in the fossil fuels that we use. So it's a really short unit. There's not a lot of vocab, but I do want to go over some of the aspects here that are important. Climate change generally is or refers to the general rise in temperature around the world, about 1 degree Celsius, 3 degrees Fahrenheit over the past 100 years. This is due to an increase in human activity, such as the human population increasing and a lot more fossil fuels being burned. You can see here the data shows that the temperature of the past couple hundred years has been rising dramatically. You can see it's about 1 degree Celsius overall. A lot of different countries, a lot of different states, a lot of different areas have different numbers, but the overall average does point to, again, about being 1 degree Celsius in increase. Here's again, same type of data, different graph showing that increase. We do a lot of graphing in this unit. If you're not here for class, you're going to see just a lot. In class, we do a lot of graphs. And you can see there's some videos here that I'm not going to go through just because it's going to take forever to get through all of them. But what's causing this climate change? First, obviously, the increasing population. Second is going to be the amount of fossil fuels we're using. And then third is going to be the greenhouse effect. We're going to talk about all three here later on. Increasing population. Obviously, in the past couple hundred years, we've seen a huge dramatic increase in the amount of people on Earth, and that's a good thing. We have a lot more people because we have modern medicine, the Industrial Revolution, we have a lot more food, and just in general, we have more resources for people just in general. And again, this is a great thing because again, we're saving people and we're having more resources, but it's also causing us to have a huge increase in the number of people. You can see here for thousands of years, it stayed under 1 billion people. You can see it wasn't until about the 1500s where we even got to 500 million people. Now we're close to 8 billion people. We're seeing this huge dramatic increase in the number of people because of those aspects that I talked about just a little bit ago. Next are the fossil fuels that we're using. Obviously, since the Industrial Revolution, humans have been pumping a lot of greenhouse gases into the atmosphere because of the amount of fossil fuels we're using. Fossil fuels are like your coal, oil, natural gas, kerosene, and propane. And this is just because we're using things like cars, factories, power plants that we need that are here for the past couple hundred years. Now, two different types of resources that we are using. You can see again more graphs showing uh, the fossil fuels being burnt and how much carbon emissions that is leading to. But two of the resources we talk about in here are renewable and non-renewable. Renewable resources come from natural resources that are very quickly reproduced. That's like your solar energy, your wind energy, your hydropower. These are resources that are very quickly renewed and don't take a lot of time. Non-renewable resources are resources that are not replaced very quickly and they're replaced over a slow process like oil, coal, things like that. It's not very efficient and it produces a lot more CO2. I should say efficient. It doesn't produce a lot of, it produces a lot of CO2. That's a better way of saying it. You can again see in the past couple hundred years, we are just exploding with the amount of CO2 that each country has been producing. All right, so the last part here is the greenhouse effect. The greenhouse effect is a good thing. It's a natural thing where heat is going to be trapped in the Earth by our atmosphere. Different molecules or different gases in the atmosphere heat up the Earth and are going to trap that heat. You can see oxygen and nitrogen don't contain much heat or don't carry and don't trap much heat, but CO2, methane, and water do. And we're seeing an increase in that CO2, which leads to more heat, more solar energy to be trapped by Earth's atmosphere, which is again heating up the Earth. Here are some CO2 levels. You can see back in 1960 compared with today how they've increased. CO2 levels have been doing nothing but increasing over the past 100 years. And again, it's because of the amount of fossil fuels that we're burning. Here's another video we're going to skip. Ooh, I like showing this diagram here, the graph. This shows you over the past couple 100,000 years. There's always, I've heard the argument, well, the climate's always been changing over the past couple 100,000 years. Yeah, the climate does change over the past couple 100,000 years. It's changed forever. That's what the climate does, but it changes over thousands and thousands of years. And you can see here what the CO2 is doing and what temperature is also doing as well. It's following CO2 because CO2 levels directly influence how hot it is. And you can see what's going on here is we're seeing a huge dramatic increase in CO2, which is leading again to the temperature also rapidly increasing. And I always have, I always try to update my charts here. That's from 2007. So let's see an updated chart. Yep, it's even higher. So CO2 and temperature. Greenhouse gases like CO2 are directly affect temperature. The more CO2, what we typically see is higher temperatures, lower CO2, lower temperatures, and we've seen this for centuries and centuries and billions of years. More CO2, hotter temperatures, less CO2, lower temperatures. How do we know it's us that's creating the CO2? Could be maybe a natural source. Well, we know it's our CO2 because most fossil fuels contain carbon 12. It's an isotope of carbon, and we're seeing atmospheric CO2 levels with the C12 isotope increasing. We know this is due to our carbon emissions because of that C12. I know it's a very abstract thought. It's very difficult to understand, but understand that we have evidence shows that yes, it's our CO2 that's causing this climate change. So how does climate change affect the world? I'm going to skip a couple graphs here, get to the glaciers melting. Glaciers, again, are melting. You can see here what it looked like before in the 40s and what it looks like today. And this is destroying ecosystems. This is destroying habitats, changing habitats, and it's also leading to those glaciers melting and that water going into the oceans. Here's another graph. Again, I love showing graphs during this unit. You can see all these glaciers melting and what that looks like in real time in the data. You can see for the past 50, 60, 70 years, how much glacier runoff and how much glaciers are decreasing in mass and how much of that mass is going into our oceans. This is a crazy video. I wish you could show it. It's like 2 minutes long. It shows you how much. I'll start it here. You can see in 1984 how much ice was there in the beginning. I'm going to fast forward to today, and how much ice there is there right now. Almost none compared to what in the beginning in 1980s was. It's again because our ice is melting at the Arctic and in the Antarctic. Show some pictures here of the before and afters. You can see the glaciers and how they are melting. And again, that goes into our ocean systems. Again, like I said, sea levels rising. You can see in the past century, the ocean levels have increased over 6 inches. And cities on the coastlines are in danger from natural disasters and other disasters like the rising sea. This is because of 2 reasons. We have the meltwater from the ice, like I just talked about, and also thermal expansion. Whenever you heat up water, it's going to expand. So these 2 reasons are because are both going to lead to the oceans rising. Again, more data. I just love showing data because it's so easy for me to teach this. Yeah, there's that you can see again more data. Sea levels are rising a little bit every year, but every year it makes a difference when again over hundreds of years you're going to see these sea levels rising. Not going to watch this video. Another thing that's happening is with the amount of CO2 in our atmosphere increasing, you're also seeing an increase in the CO2 in the oceans, which is also leading to a decrease in the acidity, which means it becomes more acidic. Oceans are 30% more acidic now than they were years ago, and that's leading to major changes in ecosystem. It's called ocean acidification. This is very dangerous for our ocean life. We're seeing that a lot of our oceans are like the species are decreasing in population and number, and more than 1 billion people rely on Earth's oceans for food. So you can think about 1 billion starving people, what that's going to lead to if we keep on going down this route. Again, I like showing the before and after images, before and after of this acidification and how it happens. Yeah, this is what happens in the oceans when acidifications hit an area, and we're seeing this all over the world. Another video I'm not going to show. Natural disasters. These are increasing not only in number but in scale, and this affects billions of dollars. And I always like to relate this to, it might not directly affect you right now. Like you might not live on the coastline or an area where this does, like in Florida where we have a lot of hurricanes, or in flooding where or places where we have a lot of flooding. But I always say that we have to help these people out, and governments help these people out by using tax dollars to fund these people and to help their repair, which we should do. We should help people out there in need. But again, we all pay taxes, so this is something that's just everyone's going to have to deal with in the future to help these people out. You can see again more and more natural disasters occurring in the past 150 years. All right, the scientific consensus. What this is showing you is the overall consensus of the data and how it's supported by scientists who have evidence that say, hey, this is not just some random thing happening. This is being caused by human activity. The climate change that we're seeing is due to human activity, the increase in fossil fuels, the amount of CO2 in the atmosphere. 97% of climate scientists agree that it is due to human activity. The analogy I give is if you have 97 out of 100 doctors saying you should get your appendix out, do you think it should be you should get your appendix out, or do you think you'll be safe without it? Yeah, or with it? Yeah, you should probably get your appendix out. Again, 97% agree that the climate is changing due to human activity. Another video. I always like showing these graphs too in this animation. These are different. You can see here. I'll move my picture. These are different agencies, different government or national agencies, and they look at and they interpret the data in different ways. But you can see they all come to the same conclusion that again, the Earth's temperatures are rising over the past 100 years. It doesn't matter what country they're from or what organization or how they crunch the data. They're coming to the same exact conclusion where yes, temperatures are rising. So what can we do? So I give you a lot of doom and gloom. Live more sustainably. And there's a lot of different ways that you can do that. You can eat less meat. You can live more. You can turn off lights when you're not using them. You can be more energy efficient. You can see invest in energy efficient appliances. There's a lot of ways you can live sustainably, and doing a little bit each day will help. It's not We're not asking people to you know don't eat meat ever again, or we're going to outlaw all these cars. No, what we're saying is just trying to make decisions that are more sustainable for the environment. Educate your friends and family. Make sure they know what's going on and how to help the environment. Support programs and initiatives that help the transfer of energy consumption from fossil fuels to alternative energies, and also recycle. So there's a lot that each person can do, but we also need the governments and we need large corporations. We need everyone just in general to help combat this climate change. This is actually the end of the chapter. That's not a very far or not a very long chapter, but I hope you enjoyed it.